Hello and welcome to my channel, Just a Guy Who Likes Math. Today we're going to be converting repeating decimals to fractions. Just a quick little story before we get started. This was actually part of my math class, part of my syllabus, and for some reason during the exam or even while practicing, I used to just love doing these. Maybe it's because it's like a quick little mental quiz for me. But yeah, let's get started. We're actually going to get started with an example. So let's say we have the number 0.777 and the 7 goes on forever. So we're just gonna kind of make it easier to say, basically. So we're gonna say 0.7 bar, and the bar, basically any and all digits below the bar after the decimal, they just continue forever. So in this example, it's 0.777. If we had 0.36 bar, the bar would be above the 3 and the 6, and it would just signify 0.363636. Okay, perfect. Let's go to step 1, which is let x equal 0.7 bar. So we just rename this, the decimal, to x. Whoops, I forgot the 1. Step 2 is, let's actually take 10x, which would be 10 times 0.777 is 7.777. And now step 3 equals 10x minus x equals 7.777 minus 0.777 is 7, right? Just a nice little integer. And now we could just, this is actually 9x equals 7, so x equals 7 divided by 9. Perfect, this is what we wanted to do. We had a decimal in the beginning and we converted into a fraction. Let me actually now explain the steps. Step 1 is fairly simple. We just rename it x equals 0.7, or the whatever number you have. Step 2 equals 10 times 10x equals 7.7. So why do we take 10? We actually take a power of 10, not necessarily 10 always. And the power is determined by, after the decimal, after how many digits does the repeating continue. So we have 0.77, so after the first digit, the repeating continued, so we use 10 to the 1, which is 10. If we had a number, say 0.36, we would have, after the 36, the repeating would have continued. So after 2 digits, the repeating would have continued, so we would have taken 100 in that case. But we'll actually do that in the next example. Let me explain step 3. We just take 10x minus x, and the reason we do this is because we want a integer on the right hand side. And in the next example, we'll use different numbers. But yeah, as long as you get an integer here, the next part is simple. We just get 9x equals 7, rearrange it, we get the fraction. Okay, let me do another example. This will be a little harder. Actually, let's just do 0.36 bar. So step 1 is let x equal 0.36 bar. So we have 10x equals 3.6, but there's kind of no way to get an integer from these two. So we do 100x equals 36.36 bar, right? And it's, I guess you can see from here, we get a decimal if we do 36.36 minus 0.3636. So let's do 100x minus x equals this minus this equals just the integer 36. 99x equals 36. Therefore, x has to equal 36 divided by 99. Yep, we started with an integer. We started with a decimal, and we ended up with a fraction, which is what we want to do. Let me just take a harder example, 0.714. Okay, this is a little different. So it's which equals 0.71414. So you see the repeating is actually on the 1, 4, not on the 7. So step 1 equals let x equal 0.714. Let's say 10x equals 7.14, which goes on forever. This actually is not helpful because 10x minus x equals some weird non-integer number. So let's take 100x. Will that help? 71.414. That actually doesn't help too. So we take 1000x equals 714.14 bar. Like I said, you don't have to do all of this. If you just remember my trick, after the decimal, after how many digits does the repeating continue? So over here, it's after 3 digits. So we take 10 to the 3, which is 1000. So we want to get so for step 3, we want to get a integer on the right-hand side. So we could do 1000x. I don't know if this helps you guys, but I'm just gonna write step 1, step 2, and step 3 over here. 1000x minus, actually, we will do 10x, because if you could, I guess, visualize in step 4, we get 1000x minus 10x equals 714.14 minus 7.141414. So we get 990x equals 707. So x equals 707 divided by 990. This is exactly what we wanted. We started with a decimal, ended up with a fraction. I'm going to do one last example. Sorry to bore you guys with examples, but I think this is important. Let's see, we have 3.257. So the 257 continues. So it's 3.257, 257, and so on. So we do step 1, which is let x equal 3.257. And now you could do 10x, 100x, 1000x, but if you use my trick, after how many numbers does the repeating continue? After 3 digits, sorry, I think I said numbers there. After 3 digits, the repeating continues. So we take 10 to the 3, which is 1000x equals, this is step 2, 1000x equals 3257.257, so on and so forth. So in step 3, I think it's good to do, in step 2, I think it's good to do, whoops, there's a little bug here. Get out of here. In step 2, it's good to do 10x, 100x, 1000x, do all those, because we see sometimes it could be 1000x minus x, could be 1000x minus 10x, 100x, depending on the situation, depending on the question. So we have step 3, 1000x minus x in this case equals this minus this, which would be 3254. Yep. So we have 999x equals 3254. So x equals 3254 divided by 999. And if you take a calculator or even a computer, and you do this calculation, you will get 3.257. Okay, we covered I think a broad range of examples. This was a little harder. It's easy, I guess, it's easy for the first example because it's only one number that's repeating, and there are no numbers to the left side of the decimal. For this example, we took 2 numbers that are repeating. For the third examples, we took 0.71414. So the 7 wasn't repeating, but just the 14. So I think that was a little challenging. And for the last example, we took 3 repeating numbers, and there's also a number on the left-hand side of the decimal. So I think we covered a lot. But if you do have any questions, feel free to leave them in the comment section below. And as always, like and subscribe. I will definitely appreciate it. It helps me out. But until next time, peace out.